I do have a master's in existential phenomenology because philosophy was what I really wanted to do.
I see.
And mind, the meaning of mind meant a lot to me, and that led to the brain.
The human brain is the most complex structure in the known universe, and we are in the middle of a scientific revolution to understand its inner workings. Join us for a conversation with world-renowned neuroscientists as they visit Rochester. I am Dr. John Foxe, Director of the Monte Institute for Neuroscience at the University of Rochester, and you are listening to NeURoscience Perspectives. Hi, I'm John Foxe. I'm the Director of the Monte Institute for Neuroscience at the University of Rochester, and I'm absolutely delighted to be here today with a good friend of mine. I'm really one of the world's leading developmental neuroscientists, Bea Luna. Bea, welcome to Rochester. It's so great to have you here on this lovely fine day.
Thank you for inviting me.
You've spent all of your career at Pittsburgh, but you are not from America, no more than I am myself. And will you tell us a little bit about your journey and where you come from and what brought you to the United States?
I was born in Chile, Santiago, Chile. And when I was a kid, I lived in DC for a couple of years, went back to Chile to an American school. And then I was, let's say, an adventurous adolescent. And I decided to come back to the States, where my father lived, for a couple of years to try it out. And that was many, many moons ago.
And was that like in high school?
Yes.
I see, okay.
Yes, as an adolescent, my poor dad. Yeah, it was, yeah.
We all have a poor dad.
I know, poor
Absolutely.
dad.
And I mean, you know, it's an interesting thing because you have a perspective from both countries about, let's say, the science engine and that. Are there things about, like, why a scientist in the US and what does the US mean for neuroscience?
No, absolutely. I mean, I've gone there regularly to give talks in the top universities in Chile. And what really impresses me is the level of their science. They do predominantly rodent models, and they publish in Science and Nature. and they're very humble about it, but very focused in what they're doing. Of course, they don't have the riches of Pittsburgh, where we have a center with 3 prismas, the 7 Tesla, an MMR, et cetera, et cetera.
Right.
So those are advantages. And I think when I was growing up as a woman, I think it would have been more difficult to have had the educational development that I had in the States and be where I am today.
Yeah, and that's been an important sort of aspect of your mission, I know, encouraging and supporting other women in the neurosciences.
Absolutely. Yeah.
Tell us, you know, what's the genesis of your interest in neurodevelopment, developmental neuroscience? I've
always been fascinated by development. First of all, I love little kids. Second of all, adolescence was a very important time in my life. I was so curious, I was so exploratory. I had, you know, journals with why, everything was a why, and I was, you know, parties and boyfriends and altered states of consciousness. All of that was all like exploration in a scientific
intellectual
way.
journey.
Yes, yes. So my graduate career started with looking at like birth to childhood. And that was fascinating, and I became obsessed with the brain. Also, I didn't tell you that I do have a master's in existential phenomenology because philosophy was what I really wanted to do.
I see.
And mind, the meaning of mind meant a lot to me, and that led to the brain. And then how does this emerge developmentally? So as a grad student, I looked at this early period, and then my conclusion, my dissertation is structural integrity is not enough because we did not see the matching that you see in adult. And I'm like, this plasticity is just so significant during development that we need to look at functional integrity. And fMRI was just emerging, not pediatric yet, but I knew it would. So I moved to John Sweeney, who you know, to John Sweeney's lab, and then adolescence became my thing. More than anything, because that's when psychiatric illnesses emerge.
Yeah. Also that period where the realization that a young person's brain in their late teens and even into their 20s was still a developing brain. It wasn't a fully formed brain, and you were part of that whole movement as well.
Oh, absolutely. I mean, when I first started, I remember my chair, who's since retired, he was like, why are you looking at adolescence? You know, it was that new. And I remember him saying, you know, I believe in you. As long as you're one of the top 5 people, and I'm thinking, there's fewer than that right now, so yes.
That's easy.
Yeah, that's an easy one, yeah. And now it's exploded.
Oh yeah, absolutely. And actually, I mean, you founded one of the major societies in the whole space in the field, the Foxe Society. You want to tell us a little bit about Foxe, how long it's been running and what it's all about?
It really was motivated by things like study for neuroscience, cognitive neuroscience, where people studying development were stuck in a little corner.
Right.
And I felt that the science was suffering as well. You know, they're all very bright, but we just weren't talking to one another. So I started to become obsessed with this idea. And talking to other colleagues, they're like, hey, these things can be done. So I rallied some friends of mine that we had promised many years ago, one day we will have our own society. I'm like, okay, I'm going to do it. Come on in. So we did it. And this was almost 10 years ago. And the idea is to bring the community of developmental cognitive neuroscience, primarily those who study humans using neuroimaging approaches, but it is essential that we have animal models and post-mortem models because we need to understand mechanisms. I always say pretty neuroimaging pictures is not sufficient. So we always try with every program chair, I always say, you have to put in, pepper it with mechanistics understanding. I followed a model of East Coast, West Coast, North America, and international. So because it is an international society. It
goes abroad and then to the East Coast and the West Coast on a revolving schedule.
On a revolving schedule.
And it's in Paris this year, which
it
is not so bad.
It is in Paris this year.
Outstanding,
yes. Very exciting after 2 virtual conferences.
This is probably a little bit of an unfair question, but as really like one of the world's leading developmental neuroscientists, when you speak to parents about what you know about neural development in the adolescent, early childhood, teenage years, are there key insights from science, from your science, from our science, that you say, here's some things you really need to know?
No, absolutely. I have these conversations often. I had them as a parent of teenagers.
Yep.
And I think, some of the realizations are that sensation-seeking, exploration, even risk-taking, is normative.
Right.
And can be adaptive. And, the adolescent is transitioning to independence and they will search and do what they want to do. My interpretation has been restricting is not necessarily going to help them. However, providing a safe, environment and an open door policy, for example, I'd rather you don't drink or smoke pot. However, if you're in trouble, I don't care if it's 4 o'clock in the morning, we will pick you up, no questions asked.
Right. Common sense stuff, really, yeah. And
it is common sense.
Giving teenagers a bit of freedom to explore because they're literally programmed to do that. Right?
Exactly.
Maybe another unfair question, like key insight, like one key insight about physiology in adolescence.
One?
No, it doesn't have to be one, but your favorite.
I think some of the things that have really emerged, particularly from our line of inquiry, it's often been perceived, and you see it in commercials and so forth, adolescents don't have a prefrontal cortex. And I think everyone's like, ha, that makes total sense. However, one insight that we have found by looking at function and structure, now we're getting more molecular, is that in fact prefrontal cortex becomes available in adolescence. It's driven by motivational forces, motivational processes, because those are operating at a greater level to motivate exploration, but within the context of the availability of prefrontal cortex. Mm-hmm. And I've seen this over and over. I informed a couple of American Medical Association briefs to the Supreme Court for life without parole. And there you really had to think about it. And you had to think about these crimes, which were very elegant in some ways, with a lot of planning, but very much driven by reward and social sorts of aspects. So I think that's been a very important insight for me about adolescence. I have many more, But that's one that's been quite critical.
Let's flip to the future, because I mean, we could talk for hours about the insights, and so of course we don't have that time. But where are we going? What's on the horizon here? Are there things that get you really excited about the neurosciences? Do we have all the tools we need in the tool chest at the moment, or if you had the magic wand, what would you do?
Oh wow, that's the unfair question.
That is,
Not
yeah,
the other ones.
appreciate that.
No. I think we never have all the tools.
Yeah.
And when you're looking at, for example, human neuroimaging, it's fantastic, the sorts of things that we can speak to, but they're all very much based on inferences and indirect assessments of things that people looking at cellular and molecular and neurophysiology have a closer link to. So I think not only just tools, which yes, we can improve the spatial resolution, temporal resolution, et cetera, but what I would like to see in the future is real collaborations between animal, human, postmodern, people really talking together.
Yeah.
Not just center grants where everybody does their own thing and they meet once a year,
right.
but actually informing one another.
Really advocating a change to the model of, rather than having all the developmental neuroscience who do imaging in one part of the building and talking to themselves, maybe a bit like you were saying about with Foxe, and trying to get all these different people at different levels together. Amazing, yeah. You won a presidential prize for your science back in the George Bush Jr. era. Was that right? And went to the White House?
Yes.
Do you want to tell us a little bit about that experience?
Yeah, that was a huge surprise and a huge boost early in my career.
Yeah.
So it's the Presidential Early Career Award for Science and Engineering. And it was me and Carl Dieseroth.
Very good.
Who won it that year, neuroscience-wise, and then there were physicists and all kinds of people. And yeah, at the time I wasn't too thrilled. I would have much rather have had Obama give me, but it was wonderful.
Yeah.
And I do remember seeing Carl Dieseroth give a talk a few years after we got the prize, and I felt like going back and saying, I am not worthy. Please take my back.
Well, for our viewers and listeners who may not all know who Carl Dieseroth is, he's the sort of founder of optogenetics, which is one of the extraordinary techniques in the field. Yes. But definitely great company to be keeping at the White House.
I know, and he's so nice. And he says he blew up the photo of all of us, has it in his lab, so he sees me every day.
Wonderful. And that led on to you being on. You were actually on the scientific council for the NIH with Francis Collins, the director.
Yeah, I was in the advisory council for the director, the ACD, and that was a wonderful experience.
Yeah.
And a woman of color.
Right.
I'm Latina and so forth. It was funny because they were so welcoming that first day. They're like, Dr. Luna, please don't be shy. We want to hear what you have to say.
If they only knew who they were talking
to. And that's
I'm
thinking, oh my God.
Well, that's really great though, right? I mean, I imagine, you have young women in your lab. I know a few of them.
Yeah.
And, to see the boss go off to the White House, to be on the council investigators, advising the director of NIH as a Latina woman, it's it must really give them a good inspiration and confidence. I mean, and this is, you must be proud of this. I have to say.
Yeah, I not at the as it's happening, I don't realize it.
Right.
But I always feel very fortunate when people come up and say, "Oh my God, you've really inspired or motivated me to persist." And what advice do you give? And I'm like, persistence is the number one.
Number one, yeah.
Yeah.
Well, let's get maybe a little controversial. Talk to me about this work-life balance, because that's very very prominent in our trainees' minds, and they're not wrong. We when you and I came up in the sciences, it was a little bit different, and there were expectations around how you would work that were really unreasonable when you look at it. But what do you say to the young women in your lab about work-life balance? I'm being specific about the women as well.
Yes, things have evolved. When I was a postdoc, it was insane. I mean, I had little kids, and my work hours were just insane. And I don't want to do that in my laboratory.
Yeah.
So, I can work long hours sometimes. That's my choice. That doesn't mean that people around me have to. Some
Right.
choose to, some don't.
And how do you communicate that to them, though?
I'm extremely supportive. I've never said no to someone wanting to take time off.
Right.
In fact, when they take time off to see their parents, I'm like, that's wonderful.
That's what you should do.
That's
right.
what you should do, because now I have
Absolutely.
kids
Yeah.
that I want to come visit. So I'm very supportive that way. I've had lots of people marry, have children, and even like faculty in the laboratory. And it's very important for me. They're like, oh, you know, my kid is sick. I'm like, family comes first.
Family first. Yeah.
Do not come here. I don't want to hear you until everything is back to normal.
Well, I think that's
Yeah.
a fantastic
Yeah.
message for the young folks that are listening in. Last thing. I have the great good fortune of working very closely with you on one of the great projects I think ever undertaken by the National Institute of Health, the ABCD
Yes.
project. You want to say something about ABCD, what it means to you, what it means to Pittsburgh?
So ABCD is the Adolescent Brain Cognitive Developmental Study. And it's following more than 10,000 individuals from the age of 9 now to the age of 19, looking at their cognition, at brain structure and function, mental illnesses, biomarkers, stress, environment, hair, genetics, everything, because now we really we realize that is the key to understanding lifetime trajectories. What is occurring during that time period? And we know, and we had a paper out in Nature recently, really showing that if you want to have these like brain connectivity and behavior relationships, you need thousands of individuals.
That's right, yeah.
So I think it's a wonderful contribution to science. This data is available for anyone, and people are constantly mining and coming up with new questions and so forth. So I'm very happy and very proud, as I'm sure that you are as well, to be part of this amazing effort.
Excellent. Bea Luna, what a pleasure to have you in Rochester, and to get the opportunity to introduce you to our community. Thank you for being here. Thanks for the time.
Thank you. Always great to talk to you, John.